Hey everyone, today we are going to solve the Daily LeetCode challenge of 27th March 2024 and the problem statement is subarray product less than k. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array nums such that it contains only positive integers. Okay, and we have been given another integer k, and what we have to do is we have to find out the count of subarrays that has product less than k. Okay, now what is a subarray? So a subarray is a contiguous part of an array. Okay, contiguous part of array. Now let's see over here. If I'll ask that is this 10, 5 a subarray? So you'll say that yes, 10, 5 is a subarray because it is a continuous part of this nums, right? And we are not missing any elements in between. Now, if I ask that is this 10 to a subarray? So you'll say that no, this is not a subarray. Why? Because this is not continuous, right? We are selecting 10 and we are selecting 5. We are missing out 5 in between, correct? So it means it's not a continuous part of num. So it's not a subarray, okay? Now let us first find out that what is the count of subarrays that has a product less than 100 in this example, okay? So if we will write down all the possible subarrays for this num, so first of all, we'll have this 10. After that, we'll have 10, 5. Then we'll have 10, 5, 2. Then we'll have this 10, 5, 2, 6. Okay. Now we'll have 5. We'll have 5, 2. We'll have 5, 2, 6. After that, we'll have 2. We'll have 2, 6. And lastly, we will have only 6. Correct? So these are all the possible subarrays of this num. Now let us find out the product of each of the subarray. So here we can clearly see the product is 10. Here the product is 10 into 5, that is 50. Here the product is 10 into 5 into 2, which will give us 100. And here the product will be 5 to the 10, 10 10 is 100, 100 into 6 is 600. Here the product will be 5. Here the product would be 10. Here the product would be 60. Here the product would be 2. Here it would be 12. And here it would be 6. Now let us find out that which all subarrays has a product less than k. Correct. So here we can see that 10 is less than 100. Okay. Here we can see that this 50 is less than 100. Okay. Now here the product of the subarray is 100. So are we going to consider it? No, because it is not less than 100. Correct. Here the product of the subarray is 600, which is not less than 100. Here the product of the subarray is 5, which is less than 100. Here the product is 10, which is less than 100. 60 is less than 100. 2 is less than 100, 12 is less than 100, and this 6 is less than 100. So what is the count of the subarray that has a product less than k? It's 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 subarrays that has a product of less than k. So these are all the 8 subarrays that has a product less than 100. Okay. Now let's see how we can solve this problem. So we will take 2 pointers. Let this be the release pointer represented by R. So it will be initially at the 0th index, and we will have another pointer. Let this be current, and it would also be at the 0th index. Okay. We have this answer to find out the count of subarrays that has a product less than k. Okay. And initially we'll take a variable product that would be initially 1. And what we will do, we'll basically use this product to keep track of the product which we have till now for the subarray. Okay. And now let's discuss that what is our invalid case. Okay. Now, what do I mean by invalid? Invalid means that when are we not going to select a subarray as our possible answer? If the product of that subarray, is greater or equal to this k, correct? Then only we are going to say that it's an invalid subarray and we are not going to consider it, correct? So what we'll do is, while this product would be greater than equal to k, what we'll do, we'll simply try to make our product less than k. And how we'll do it? We will do this by dividing product with the element present at the release pointer, that is with nums of release, correct? And what we will do after doing that, we'll simply increment our release pointer, right? So now let's quickly do a dry run. So first of all, what would be our product? Our product would be product into nums of current. So what is nums of current? Nums of current is 10. So if we'll multiply our product with 10, what we'll get? We'll get a 10. Now we'll check, is our product greater than equal to k? So our product is not greater than equal to k. So what does it mean? It means that it's a valid subarray. So what are we going to do is, we are going to add current minus release plus 1. Okay, so what is current? Current is 0. What is release? Release is 0 plus 1. So what we'll get? We'll get 1. So we'll add 1 to our answer. And what does this 1 represent? This one represents that we have got a subarray that has a product less than k. And which is that subarray? It's this 10. Correct. And we can see that we have got this 10. Correct. Now what we'll do, we'll increment the current pointer. So current pointer is over here. So what we'll do now, we'll multiply this 5 to our product. So our product was 10. We'll multiply it with 5. We'll get a 50. Now what we'll do, we'll check that is this 50 greater than equal to k. So k is 100. So we can clearly see that 50 is not greater than equal to k. So it means it's not an invalid case. Correct. So what we'll do, we will add current. What is current? 1. So we'll add current minus release plus 1. So what we'll get? We'll get 2. So we'll add 2 to our answer. Now what does this 2 represent? This 2 represent that we have got 2 subarrays that has a product less than k. And which are those 2 subarrays? The first subarray is this 5 and the second subarray is this 10, 5. So it means that we have got this 10, 5 and we have got this 5 so far. Okay. Now what we will do? Now we will simply move our current pointer forward. So our current pointer will now point at the second index. So what is the value at second index? It's 2. Correct. So what we'll do, we'll multiply this 2 to our product. So what we'll get? We'll get 100. Now we'll check, is this 100 greater than equal to k? So we can see that 100 is equal to k, right? So it means that it's an invalid case. It means that this subarray, we are not going to consider it, correct? So what we'll do, we'll say that while our product is greater than equal to k, divide our product with nums of release, correct? So what is nums of release? Nums of release is 10. So what we'll do, we'll divide 100 with 10. So if we'll divide 100 with 10, what we'll get? We'll get a 10. So after dividing, what are we doing? We are incrementing this release pointer, indicating that we have released this element from our product. And how did we release it from our product? Since we earlier multiplied this to our product. So in order to release it from our product, we are dividing it, right? So now we'll move the release pointer. So the release pointer is at 5. Now what we'll do, we'll again check that is our product greater than equal to 100. So we can clearly see that 10 is not greater than equal to 100. So what we will do, it means that we are in a valid window. Correct. That is, we have got a subarray that has a product less than k. Correct. So what we'll do, we will find out current minus release plus 1. So what is current? Current is 2. What is release? Release is now 1. So current minus release plus 1, it will give us 2. Correct. So what does this 2 indicate? This 2 indicates that we have got 2 subarrays that has a product less than k. And which are those subarrays? It's this 2 and it's this 5. Correct. So what does it mean? It means that we have got these 2 subarrays. Correct. Now what we will do? Now we will move our current pointer forward. So our current pointer will move to the third index. Now what we will do? We will multiply this 6 to our product. So if we'll multiply 6 to our product, what we will get? We'll get 60. Now we'll check, is this 60 greater than equal to 100? So 60 is not greater than equal to 100, right? So it means that we are not in an invalid case. So what we'll do? We will add current minus release plus 1 to answer. So what is current? Current is 3. What is release? Release is 1 plus 1. So what we'll get? We'll get 3. So we'll add 3 to our answer. And what does this 3 indicate? This 3 indicate that we have got 3 subarrays that has a product less than k. And what are those subarrays? It's this 6. It's 2, 6. That is this one. And it's 5, 2, 6. Correct? 5, 2, 6. So it's this one. Now what we'll do, we'll move the current pointer forward so we can clearly see that we don't have any more elements left in them. So what does it mean? It means that we have processed all of its elements and we have got the answer. And what is the answer? The answer is 3 plus 2 plus 2 plus 1, which is nothing but 8. Correct? And we can see over here that we were successfully able to find out all these subarrays in this nums by doing this try run. Correct? So we will simply return 8 as the answer. Fine. Now let's quickly do a recap of this problem. So what are we going to do is we are initially going to have 2 pointers, release and current. Both of them would be at the 0th index initially. And we are going to have a variable product which would be initially 1 and answer would be initially 0. So basically answer is keeping track of the subarrays count that has a product less than k, and product is keeping track of the product of the particular subarray. Correct? Now we know that what is our invalid case. Our invalid case is that whenever our product will be greater than equal to k. Correct? In that case, we don't want to consider that subarray. So what we'll do, we will try to make that product valid. So how we can make that product valid? We can make that product valid by making it lesser than k. So what we will do for making it lesser than k, we will divide the product by the element present at the release pointer. And after dividing it, we will simply increment the release pointer. Okay. And the moment we will find that a window is valid. So what does it means to have a valid window? It means that that subarray has a product less than k. Correct. So whenever a subarray has a product less than k, then what we'll do? We'll simply add current minus release plus 1 to our answer. Correct. So now that you have understood the solution, so let's quickly code this. So we will start on by creating a variable answer which would be initially 0, and this answer will keep track of the count of subarray that has a product less than k. Okay. Then we'll take another variable product which would be initially 1. It is used to keep track of the product of the subarray. And we'll take a pointer release which would be pointing at the 0th index initially. Now what we will do? We will iterate over the given array nums. Correct? So current is equal to 0. Current less than nums dot size. Current plus plus. Now what we have to do? We have to first multiply the current element to our product. Correct? So what we'll do? We'll say product is equal to product into nums of current. Correct? Now, after multiplying the current element to the product, what we have to do? We have to check for the invalid case, right? And when are we going to say that a subarray is invalid? A subarray is invalid if it has a product greater than equal to k. So, if a subarray has a product greater than equal to k, so what are we going to do? We are going to make its product less than k until when? Until when are we going to do it? Until we don't get a product less than k. So how are we going to make a product less than k? We are going to make a product less than k by dividing product by the element present at the release pointer. Correct? After that, we'll simply increment the release pointer. Fine. Now we have to add one more check in this while loop, and that's that this release pointer should be either less than or equal to the current pointer. Correct? Now, once we have come out of this while loop, or if we have not gone inside this while loop, so what does it mean? It means that we are in a valid window. That is, it means that we have a subarray that has a product less than k. So what do we have to do in that case? We have to simply add the count of that subarray to our answer. Correct? So what we'll do? We'll say current minus release plus 1. Because how are we finding out the count of subarray? We are finding it by adding current minus release plus 1 to our answer. Right? And finally, what we'll do? Finally, we'll return our answer. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider the size of the given array as n, then the total time complexity would be order of n. Let's see how. So what we are doing over here is we are iterating over all the elements present in nums. Correct? So if we have n elements in nums, so it means that we are going to iterate over all the n elements in order to find out the count of subarrays that has a product less than k. So it means that this for loop is going to cost us an order of n time complexity. Correct? And we are not using any extra space from our end, because of which the space complexity would be order of 1. So that's all about today's daily LeetCode challenge. Thank you.